Okay, students, right now I have to provide for you some brief insights about current topic, next one, which is topic 8. So we continue studying about methods which is related to decision-making process in biostatistics. So right now, pay some attention for methods for identification relation between variables. Necessary theoretical backgrounds have been provided in today's part of lecture. So right now, some just notice on practice. So first of all, of course, you have to check your practical class material, which this time concentrated only on one method of identification relationship between variables, which is correlation, and actually give answer how strongly pairs of variables could be related. So usually it's applicable for two continuous or discrete variables. So quantity variables has to be used in this analysis. Measures is coefficient of correlation, so close it's to 1 or -1, so stronger correlation is positive or negative. And here is we can to provide assessment about how strong really correlation is. As you can see, about 0, it's negligible. Depending to distribution type of your data, we can deal with parametric Pearson correlation or Spearman's-Rand correlation. So if you need to calculate it manually given formulas, and with spreadsheet like Excel or any statistical tool supports correlation. For example, here is a given for example for Excel or Google spreadsheet or so. We can do it with function. In this case, it will be calculate for you only Pearson parametric correlation. So unfortunately, when we do the same way, you can use a correlation tool from this toolbox, which also provide even pairs of correlation if you want to analyze multiply variables. So that's about parametric correlation. Speaking of not parametric correlation, unfortunately, you have to implement Spearman-Rand correlation manually. So you have to, here is given also example how to do it if necessary. So you have to do it manually by using this formula. That's actually almost all about this introduction. Here is given a very brief example which demonstrate ideal correlation, which in fact never happens in reality, but like more or less we can do it. So of course you have to complete quiz on this, check video resources which is available, if necessary additional readings provide, topics about available, additional topics on Excel Easy about correlation, etc. And then your task which you have to complete. So everybody will be given like by variance by some description of problem with some numerical data set, and you have to implement given steps. Pay attention that you have to create few different chat types, like two different chats instances, linear to visualize the set itself, and scatter to visualize the relationship between variables in graphical manner. Then you have to evaluate distribution type. Okay, and calculate correlation in two ways. So let me give for you some brief example for this. Okay, let me create spreadsheet. Let me create spreadsheet. To be new one. Great. Let me use it. Okay, let it be 2 samples, or maybe even 3 samples. Maybe I will use one of my example. Instead, input random variable, I will use what I'm available here. Okay, not exactly these things. Okay, anyway, I will use part of this data just to make things faster. Okay, we have 2 groups of data. And let me quickly create group C. Okay, something like this, just to visualize possible 3 cases. So, first of all, we will consider 2 groups. 2 groups, this one we will left for later time. Okay, let's consider these 2 groups. As it's spoken in task, you have to insert, create linear chart, to visualize possible correlation between x-axis. Oh no. No, it's better to add the, okay, we will add the one by one. Insert chart. So here is we have group A. And if I want add the series, it has to be group B. Okay, and even same way I can add the series for group C. So this way we can visualize, only visualize data and have a clue about potential correlation. So as it's visible, group A and B might be correlated, one between us. Okay, to clearly determine this more clearly visual way, I can use another chart type. I have to use scatter with chart, and here is this will show for me a clear correlation between 2 variables. As you can see, there we have dependency between group A and B. And it would be fine to have tag our data series with our trend line. Here is actually we need this trend line. We need to have a square assessment, coefficient of determination, which actually give us potential answer about presence of correlation between this variable or no. Okay, so here it is. Here it is. Good. In case if we have three variables, of course, if you want to determine the relationship between other, in this manner, you have to add the more data series, more groups. For example, you can, this way, if we have a group as along x-axis, you can add the yet another data series to determine the same time correlation between A and C, but not B and C. Let me show this. I will add the group C. I will add the group C. And here is we have yet another group, and here is also possible to not sure if it will be possible. Okay, I can add the third line for C as well, and display square as well. So in this case, we go to visual assessment about visual correlation between A and B and A and C, but not B and C. If you want to have it for B and C, you have to construct another scatter plot only this way. Actually, in your practical task, you have only two data series, so you don't need such complication. It's just in case I show for you how this work. So in this case, we have again add on the series. We have add sorry, not line again. Yeah, this way. So potentially we could see a potential correlation between A and B, B and C, but not A and C. As from a square value, which is take a look. But even in all this case, it's relatively low. So that's that part of task when you have to calculate. You have to visualize data with chart. And okay, next steps, in fact, you have to verify if you can use parametric or not parametric correlation. For this, you have to calculate skewness kurtosis. Okay, get back to this. And of course, repeat it for all these variables. Then you have to use good. I will do it this. Because unfortunately, Excel tried to adjust our chart. Data range. Let's force only to 17. Only to 17. Nothing changed right now, fine. Here is we have skewness. And kurtosis again. Okay, pretty mostly low value, except only one kurtosis too high. So again, you have to use table from previous class, from topic 7, to determine, here is this one, to determine, oh, sorry, not this one, practical class material, of course. and that last table to determine is it your data fit normal distribution or not. All value pretty small except one kurtosis, which is definitely above given limits. For 16, we have 16 values, so we have to use those critical value. Those critical value, here is for 20 and here is for skewness. So here is given critical value. Let me provide this and this pair for kurtosis. Okay. So here is given critical value, and as you can see, this one exceeded. This two exceeded. Yeah, this pair exceeded. So what do we have? We have two samples which definitely fit normal distribution, and one which is might have some different distribution. ND, and here is questionable. Actually, deviation not very high, but some substantial for at least this value. Okay, anyway, we can try to make between group A and C, we definitely can try and make calculation for parametric correlation. For A and B, okay, we can try, but result will have some doubts on this. So if we asking about, please make this conclusion. Okay, if we let me try parametric correlation. Here is all your example will having only normal distribution, so you don't need this ranking right now. Okay, this way I can calculate correlation between A and B. Analytical A to C, sorry, and here is same way. I can try, despite one variable not fit normal distribution, I can try correlation between A and B. So technically it's will work in AB. In both cases, as you can see, we have very weak correlation. If you compare with those materials, you will see that it's almost negligible correlation. Almost negligible. So unfortunately, that's happened with our observation. Sometimes, like we have suspicion, it's about possibility of linear correlation, but it does not have yet. And one more way to calculate. So that's actually answer. Correlation very weak, very negligible. And anyway, one more approach to calculate correlation coefficient is by using Excel minor analysis toolbar, and here is we will have also correlation tool, which allows to us to having all possible correlation, because I made calculation A and B, A and C, but not B and C right now, not B and C, taking this into account. So this way I can do it. I can do it manually, of course, but I can do it with this tool. However, first of all, my data in columns, and let me place result somewhere there. E26, oh yeah, okay, pick it up. And so here is, we have all correlation, same as this case, we have correlation between B and C, third correlation, which is also weak, which is also this pair, exactly the same like I did, like I get manually, and this one between BC also less than 0.3. So again, we are talking about weak correlation in all three cases. So in this case, there is no actual relationship between these data variables. That's actually fine. So of course, your final conclusion have to somehow answer about real world questions. So if we have no correlation between variables, so probably there is no relation between those assessments, nurse and physician assessments. Like if it would be this data. That's actually all about topic 8. Of course, those conclusions has to be written down in your online document.